Hello students, today I talk about the logistic growth. The logistic growth is proportional both to the current amount and to the difference between the current amount and constant A. The differential equation of logistic growth is y prime k times y times a minus y and y equal a over 1 plus c times e to the power of minus k times a times t. You should concern the exponential growth, the restricted growth, and the logistic growth. Number 1. The exponential growth is proportional to the current amount. Number 2. The restricted growth is proportional to the difference between the current amount and the constant A. Number 3. The logistic growth is proportional both to the current amount and to the difference. Let's solve this problem with me. Follow me. Okay, let's look at the concept with me. Okay, let's compare these three growth functions. Today, I talk about the logistic growth. Logistic growth is the rate of change of a quantity is proportional both the amount of the quantity, in other words, this is current amount, and to the difference between the fixed constant A and its amount. Yeah. In other words, this function y prime k times y times a minus y. This is current quantity. This is current quantity. This is constant A. That is limit value. Let's compare three functions. Exponential growth. Exponential growth, the rate of change be proportional to the amount present. In other words, dy, this part is dy over dt. Proportional to, we need a constant k times current amount y. So you should remember these two forms. This equation and this statement. Look at the problem. Look at the concept restricted growth. Restricted growth, the rate of change of a quantity. This part is not important. You just focused on the latter part. The rate of change of the quantity is proportional to the difference between the amount and the fixed constant. So this part is dy over dt. This part is k. This part is a minus ft. In other words, this is a minus y. So I can rewrite dy over dt equal k times a minus y. So you can get this function. Number 3, the logistic growth. The logistic growth, the rate of change of quantity is proportional both the current amount and the difference. So we can write like this. Okay. To understand this equation deeply, let's prove this. Let's prove this equation. This equation equal y prime equal k times y times a minus y, where k and a are both positive. The solution is like this. This is my starting point. This is my goal. So I can rewrite dy over dt equal k times y, a minus y. Separate these variables respectively. So 1 over y times a minus y dy k times dt. apply integral like this. To solve this integral, I will separate this fraction like this. 1 over 8, 1 over, yeah, y times a minus y. Put this equation like this. A over y, b over a minus y. To find this coefficient ab, let's combine again. Y times a minus y, small a times large a minus y plus b times y. So, yeah, combine same variable like minus a plus by plus small a times y over y times a minus y. This is same the first part. So there is no coefficient of y, so minus a plus b equals 0. This part is 1. Small a times large a equals 1. We should find small a and small b, so a equals 1 over large a. By using this equation, a equals b, so b equals 1 over large a. So I can rewrite this equation. This is 1 over a over y plus 1 over a minus y. Yeah, take this again. So this is extract 1 over a integral. This is 1 over y plus 1 over a minus y. A minus y dy plus c1 in kt plus c2. Okay, move this. So 1 over a integral 1 over y plus 1 over a minus y dy kt plus c2 minus c1. It is just a c. So apply, multiply a on both sides. Integral 1 over y plus 1 over a minus y dy akt plus ca. This is constant. Again, c. Let's calculate the front part. This is ln y. This is minus ln a minus y. This is akt plus c. To find y function, let's combine this ln. So ln y over a minus y akt plus c. To vanish ln y over a minus y e to the power of akt plus c. Separate the latter part, e to the power of akt times e to the power of c. It is just the c. So I can rewrite y over a minus y c times e to the power of akt. To find y, inverse this equation like this. A minus y over y. This is 1 over c times e to the power of akt. Okay. This is, I can rewrite, this is 1 over c times e to the power of minus akt. It is a c. Okay. So, and separate like this here. So a over y minus 1 c times e to the power of minus akt. Move 1 on the right hand side. A over y equals c times e to the power of minus akt plus 1. Okay. Inverse again to find y. So y over a, this is 1 over c times e to the power of minus akt plus 1. Multiply a on both sides. So y equals c times e to the power of minus akt the denominator is like this and numerator part is A. So check it again. This is a starting point. This is my goal. My goal is my goal. This is my goal. Far away. So this is the same. So I prove this process. It is important for you to calculate the logistic growth. So keep in mind this process and repeat this process to understand deeply. Okay, look at the problem number 1. A population Y changes at the rate modeled by the differential equation. Yeah, this form of the logistic growth, where T is measured in years, while the all values of Y for which of the population is increasing at a decreasing rate. Okay. This form is logistic growth. Logistic growth form is Y prime, K times Y, A minus Y. In other words, logistic growth is proportional to the current amount Y, and the difference, this form is the same. So it is the logistic growth form. Look at our purpose. The population is increasing. This is dy over dt is positive. This means that at a rate, at a decreasing rate, this means that y2 prime is negative. Yeah, this is y prime. Yeah, this is y prime. To apply this to assumption, y prime is 0.3y, 700 minus y is positive. Divide by 0.3 on both sides. This is positive, so y 7 minus y. Multiply minus on both sides, so y minus. So the range of y from 0 to 700. To apply the second assumption, differentiate this equation one more time, y2 prime. So 0.3, 700 minus y, 0.3y minus 1. This is less than 0. Divide by 0.3 on both sides, 7 minus y, yeah, minus y. So minus 2 times y, minus 700. Divide by minus 2 on both sides, y is more than 350. So this part is 700. This range is, yeah. The arrow is like this, so this part is here. So the answer is y from 350 to 700. The answer is C. Okay. Look at the problem number 5. Let K be a positive constant. Which of the following is a logistic differential equation? Logistic differential equation is y prime K times y, A minus y. This is limit value. So, and constant. Yeah, find the similar form. Yeah, this is current amount. This is the difference. So the answer is This is current amount y. This is the difference between the current amount and the constant a. This is limit value. Because this form is like this, this value is 21. Yeah. In this case, the form is like this. This value is a. So this value is limit value of the logistic growth. Okay. Look at the problem 6. Okay. The population P of a rabbit on a small island grows at a rate that is jointly proportional to the size of the rabbit population and the difference between the rabbit population and the carrying capacity of the population. If the carrying capacity of the population is 3,600 rabbits, which of the following differential equation best model the growth rate of the rabbit population in terms of t, where k is constant? Okay. Some problems offer the statements like this. Proportional to the size of the rabbit population. This is current amount, usually y. This is the difference between the rabbit population and the carrying capacity of the population. This is a minus y. Because of these words, proportional to, we need k. So dy over dt equal k times y, a minus y. The carrying capacity of the population is 3,600. So we know A is 3,600. So I can rewrite, the unknown is P. So I can rewrite dP over dt equal K times P 3,600 minus P. So find this form. So the answer is E. Okay. Look at the problem 8. Some problems provide these statements proportional to the current population and the difference. But other problems provided this form. This is the same statements because this is definition of the logistic growth. So keep in mind that this two expression proportional to the current population and the difference, or this form dp or dt. In other words, this form dy over dt equal k times y times a minus y. It is important for you to recognize the logistic growth problems. If you identify these problems, you can approach at the solution easily. Look at the problem 8. The total number of reported cases of illness in a large city T days after the start of the outbreak is modeled by the function y equal ft. That is a solution to the logistic differential equation like this. Nice equation. If there are 8 reported cases of the illness initially, what is the limiting value for the total number of reported cases of the illness as t increases? Okay. Yeah, this form is k times y times a minus y. So this is dy over dt. This is a logistic form. The limit value is 1,700. Oh, what is the limit value? Oh, okay. The answer is 1,700. Yeah, it's easy. Okay. Look at the problem 14. Yeah. Yeah. Okay. Yeah. Which of the following differential equation for a population P could be modeled? The logistic growth shown in the figure above. Oh, in this graph, the rate value is 200. Okay. Yeah, to figure out this form, dp over dt, k times p, a minus p. Yeah. So to make this form, you should extract constant k and p in this example. So first example is p 0.001 p. Okay. So the latter part multiply 1,000 inverse number. Yeah, so this is 200 minus p, this form. So yeah, limit value is 200. Oh, this is answer. Yeah, second is extract 1.001 p and multiply 1,000 like this, then 100 minus p. This limit value is 100. Yeah. In this case, extract 0.2, yeah, 0.2 p like this. This is 1 over 5, so inverse number is 5. So p minus, yeah, multiply 5 like this. And extract minus, yeah. So this is 0.2 p, 0.005 minus p. Okay. Yeah. And D is extract 0.001 p like this. Multiply 1,000, the latter part, 300 minus p. Limit value is 300. Extract in this case p and p minus, yeah, 0, yeah, 0.1. So extract minus p 0.01 minus p. Okay. Okay. I finished the problem. Keep in mind the definition of the logistic growth. Logistic growth is proportional to the current amount and the difference. In the problems, many problems provide the information, the statements of the definition or the equation, dy over dt equal k times y times a minus y. Thank you for listening. I'm rooting for you always. Good luck. Bye-bye.